Hello everyone and welcome to this lesson. Today we're going to be looking at a type of number called a prime number. Now if I take the number 52, I can rewrite this number as 26 times 2, or I could even rewrite it as 13 times 4. This is nothing special. These four numbers here, they're just factors of 52. And in fact most whole numbers can be written as the product of two other whole numbers. However, this is not true for the prime number. Prime numbers can only be divided by 1 and themselves. So on the screen here we've got a list of just the normal whole numbers, so 1, 2, 3, 4, 5 all the way up to 20. And just to kind of give a better idea of what a prime number is, we're going to go through this list of numbers and try and identify all the primes that we have in this list here. So we can start at the number 1. Now this brings us nicely onto a little fact that you will have to remember about prime numbers, and that is that the number 1 is not a prime number. Because prime numbers have to be divisible by 1 and themselves, we say that 1 isn't a prime number because 1 and itself are the same thing. You don't really need to understand why it's not prime. As long as you just memorize the fact that 1 is not prime in your exam, you'll be fine. So we can move on now to 2. 2 cannot be divided by anything else, so we say 2 is prime. 3 is prime. 4 can be divided by 2, so 4 is not prime. 5 is prime. 6 can be divided by 3 and 2, so 6 isn't prime. 7 is prime. 8 can be divided by 2. 9 can be divided by 3. 10 can be divided by 5. 11 is prime. 12 has a whole load of factors, 2, 3, 4, 6. Moving on to 13. 13 is prime. 14 can be divided by 7. 15 can be divided by 5. 16 can be divided by 4. 17 is prime. 18 can be divided by 9. 19 is prime, and then finally 20 can be divided by 2, so 20 is not prime. Okay, so you can see from just the list of the first 20 numbers here, a good few of these numbers are prime numbers. So now we understand a little bit about what a prime number actually is, we can go on to look at what we call unique prime factorization. Now that sounds like a really scary and complicated name, but the concept is actually quite a simple one. Basically, we say that any whole number can be written as a sequence of multiplied prime numbers, and only one sequence exists per number. The best way to explain this is to use an example. So we've got a number on the screen here, 288, and we're going to just keep dividing by factors of 288 until we eventually reach a prime number. That might not make sense with just me saying it like that, but as we get into the method here, I'm sure you'll understand it just fine. So we'll start with the fact that 288 can be written as 144 times 2. So we can split 288 into two different branches here with 144 on one end and 2 on the other end. Now, you'll know from the previous slide that 2 is a prime number, so 2 can't be divided anymore. We're going to stop there. So we'll circle 2 and ignore that branch. Now we can move on and look back at the 144 here. 144 isn't prime, and we can split it up again into 72 and 2. Again, 2's prime, so we'll circle that and go back to looking at the 72 branch here. 72 isn't prime, it can be rewritten as 36 times 2, and we'll circle the 2 because that's prime and go back to looking at the 36. 36 is 18 times 2, circle the 2 because it's prime. Look at the 18, that can be written as 9 times 2, so we'll circle the 2 again. And finally, this 9 here, we can write that as 3 times 3. 3 is a prime number, so we can circle both of these 3's, and as you can see now, the tree stops because we can't expand any branch by any more. So what we're left with is what we call the factor tree of the number 288. And actually, if we take every single number that we've circled here and multiply them all together, what we'll end up with is our original number of 288. Now, these numbers here are all prime numbers. We know that because we only stopped and circled them when they were prime. So this is what we call the unique prime factorization of 288. 3 times 3 times 2 times 2 times 2 times 2 times 2. As we were saying at the start, any number can be written as a sequence of multiplied prime numbers, so we could have done this for any number, and only one sequence exists per number. So this is a unique sequence. There's only one sequence of prime numbers that we could multiply together to get 288. And actually, we can do this now for every single layer of the tree. If we take off a 2 from our original sequence here, that'll bring us down to 144. So this is the unique prime factorization for 144. Move down another one and take off a 2. This would be the unique prime factorization of 72. And repeat the same process again to get down to 36. Divide by 2 again to get down to 18. And then lastly, we can rewrite 9 as 3 times 3. So to summarize, in this lesson we have learned that a prime number only has two factors, and they are 1 and itself. It can't be divided by any other numbers, and that any whole number can be written as a sequence of prime numbers multiplied together, and only one sequence exists per number. What I'd advise doing now is really getting to grips with being able to perform this unique prime factorization process on any number, because we use it a lot later on in the course for things like simplifying fractions, and overall it's just a really useful thing to be able to do to solve mathematical problems. Anyway, I hope this lesson was helpful. Thank you so much for watching.